think as not to delay, we might get started. So welcome to those who've joined us so far. My name is Laura Egan O'Brien. I'm the Marketing Manager for the College of Engineering and Architecture here in UCD, and I'm going to be your host for the session today. You're really welcome. This is our first webinar of our Talk Graduate Virtual Webinar Series this week. This session is all about programs within our School of Biosystems and Food Engineering. You will get a chance to hear from our Head of School, Professor Paula Burke, also some program directors for the courses that we have on offer, Professor Enda Cummins for Food Engineering, Professor Kevin MacDonald for Sustainable Energy and Green Technologies, and our newest program with Dr. Dimitrios Agropoulos for Digital Technologies for Sustainable Agriculture. So it's our newest program. And then you'll also get a chance to get the student experience from one of our current students, Segun, who is doing our ME, our Biosystems Food Engineering 2-year program, and he's originally from Nigeria. So some housekeeping before we get started, just to let you know, we are recording this session today. So if you miss anything or you know anyone who couldn't attend today but would be interested in the content, we are going to pop the link to the recording up on our YouTube channel sometime early next week. And my colleague Katie O'Neill, who's also joining us, might pop a link to our YouTube channel up in the chat, so you can grab that there as well. But as I said, early next week is when it'll be up. Also, just to let you know, if you have any questions for us today, please feel free to type them in using the Q&A button, which is located in the control panel at the bottom of your screen. Type the questions in as they come to you, but we'll leave it towards the end of the session to actually get through as many questions as we have time for towards the end. And then lastly, just to let you know, the email you would have got from me giving you the link for today's webinar would have also contained a link to our event landing page. So if you haven't had a chance to check that out, it will be good. It has some user information on things like our brochures for program information, things like a link to the UCD virtual campus tour, our academic and alumni showcases. So lots of useful information there for you to pick up at a later stage if you haven't had a chance to check it out. But that's really it for me. So without further ado, I might hand it over to our Head of School, Professor Paula Burke.
Thank you very much, Laura. Good morning, everybody. You're all very welcome to this information session on our taught graduate programs within the UCD School of Biosystems and Food Engineering. So what I'm going to do is I'm just going to bring you through a little bit of an introduction to our school, and then I'm going to go through some of the programs very briefly, and then and I will be available later in case there's any questions as well. So first of all, I just want to get this onto full screen. So our school is growing. It is now comprised of 19 faculty members. We've got 3 full professors, 6 professors, 2 associate professors, and 8 assistant professors, all involved in the delivery of the range of our programs. We're supported by an administrative and technical staff team. We have a very strong research focus within our school as well, and we currently host up to 25 research staff within our school. We have a very large research student body as well. At the moment, we have around 100 research students. So what that means is that within the performance and the studies that you would do, that you've got great opportunities to link in with ongoing and current research projects and their research teams. We have a very strong funded research program running within the school, with approximately 5 million funding behind that on an annual basis. And underpinning that, we've also got a number of very well recognised researchers and academic staff based within our school. We've got 4 highly cited researchers within our academic team. So just in terms of the programs that we have, what I've got here is a list of each of the program titles of our graduate taught programs and the email address of the program director. So Professor Enda Cummins will give you an introduction to our MNSC in food engineering. Later on, Kevin MacDonald will give you an introduction to our MSc in Sustainable Energy and Green Technologies. And then Dimitrios will give you an introduction to our MSc in Digital Technologies for Sustainable Agriculture. We also have a range of other programs. We have our ME in Biosystems and Food Engineering, which Segun will go through with you. And we also have a number of recently launched graduate diplomas in bioeconomy and sustainability implementation, as well as carbon accounting and life cycle assessment. So I just thought, instead of having more writing, what I'd show is just some of the images from some of our activities over the last couple of years. So some of the images ranging on the screen there What we have is we're a very diverse school, so we try and welcome everybody, and we have a number of whole school events where everybody's invited. So it gives everybody an opportunity to network with both the staff, the postgraduate researchers, the research staff, as well as all of our taught students. So everybody's invited. As we have such a diverse school, we celebrate lots of different events that are associated with different cultures and regions over the year. And as you go through your academic programs, there's just some examples here of obviously some of the activities that we can do. So we're very strong on engagement activities and outreach, such as the soapbox event there. So Ray Cherry is a student down there at the bottom who is giving a presentation on a public street in Dublin on her project. And also then over to the right there, you can see some images of a large class group when we went in to see a novel technology processing centre within Dublin, and that's part of the engagement and the industrial visits within a number of the programs. And finally, then in the centre, just an image to capture, the graduation day, that hopefully if you register with us and you have a successful time doing your taught graduate program, that you then have within the course of 1 year, one academic year, you have the opportunity to graduate from UCD School of Biosystems and Food Engineering as well. So that's pretty much from me. There's just one other area here that I wanted to go through. So some of the facilities that we have some excellent facilities in terms of research and teaching provision within the school. We have an extensive spectral imaging and advanced process analytical technology suites. We have non-thermal process technology and intervention suites. We have developed a circular bioeconomy suite where we have a biosensors laboratory, a biofinery laboratory, bioresource recovery laboratory, and also a carbon lab. We're establishing the digital agriculture lab and also the environmental analysis suite supporting the environmental technology program, but specifically with an olfactometry lab. So there's a wide range of cutting edge technologies there that you can learn about and get exposure to during your time here within one of our graduate taught programs. So I'll hand you over now to, I think, back to Laura for the moment. Thank you very much.
Thank you very much, Paula. I really appreciate that. So next up, we have Professor Kevin MacDonald. As I said at the start, he's our Programme Director for Sustainable Energy and Green Technologies.
Thanks, Laura. Thank you very much. So I'll just bring up the slides. And can you see that?
So, Kevin, they're just still in presenter mode.
Okay, 1 second now. Yeah, it's not switching for me. Okay. Just okay, it's just not coming up for 1 second. Okay, so I'll just try that again. So what I want to talk to you about is the Sustainable Energy and Green Technologies program. And I understand it's probably not coming up. Yeah, it's just not swapping for some reason. Not to worry. So this program runs over the 3 semesters. Primarily what I want to explain to you a little bit about was the different content that you'll get an opportunity to study and work with us on. So the first semester, we really introduce you to the core principles associated with the program. So ideas around sustainable energy, what does it mean? Where does it fit into the global economy? We'll talk to you about energy systems. We'll talk to you about, waste to energy. How can we look at utilizing our resources far more effectively? We'll also introduce you to 2 modules which will run throughout your program, which is the research and teaching methods module and also your biosystem engineering thesis. So the thesis accounts for 30 credits out of your 90 credits program. So it's a really important part of it. And we'd like you to engage with that from day one. And I'll talk to you a little bit more about that in just a moment. In your second semester, you get to talk about more involvement in life cycle assessment. We'll talk to you about energy system integration. So how do we look at different types of energies, their role, the different types of strategies that we have for energy engagement across the European Union, using some of the case laws and examples within the European Union, and how that plays out across the global stage as well with regard to how we're developing different energy programs. The bioresources and biorefinery technology brings in the new areas of technology and development where we look at recovering different types of resources. We're looking at developing novel and new approaches and ways to how we use our resources more effectively, particularly from an energy point of view. So, for example, what types of materials can we recover? How can we approach it in a more circular manner so we reutilize materials as much as possible? Because, if we think about it, everything revolves around carbon and how we use carbon. We're made out of carbon. The food we eat is carbon. The clothes that we have, the infrastructure, it's built out of carbon. So we need to see how we utilize that carbon much more effectively and how we can recover and reutilize it in different forms and different techniques as well. In semester 3, the focus throughout the summer term is really going to be on the thesis topic. So you would start that in your first trimester and you would follow it through in the second trimester, but we're aware of the fact that you're also doing quite a lot of modules in those periods. So we have a light touch with regard to the work on your thesis at that point in time. And it's really the summer term, the third trimester, where you get the in-depth work done on your thesis. Within the program, as Professor Paula Burke has mentioned too, we have a lot of guest speakers that come in. They talk to you about their experiences in the industry, what sustainable energy, what green technology means to them, how they've had to evolve with regard to changing legislation, and we get a number of site visits associated with that as well. So your teaching load is spread over those 3 semesters, and really, while the third semester is for your thesis, we need you to engage with that from pretty much the start of the term. And you need to apply yourself to that kind of 1 day a week to think about it, do the literature review, start compiling some ideas, get your objectives together, and that enables you to work your way through the thesis module. The types of topics you might like to explore in this thesis for the program, we cover a range of different areas. So, for example, it could be in domestic electricity, it could be in third generation solar, it could be in, for example, zero carbon technologies. How does an industry evolve to becoming a zero carbon footprint industry? So we have students working in those areas. We look at energy saving techniques within the infrastructure, the national infrastructure that we have in the country as a case study. So, for example, road technology. How could we reduce the amount of energy associated with transport, but also with street lighting associated with our infrastructure? We look at energy efficiency in buildings as well. A lot of these projects, they're linked to ongoing international research projects that we have. So as a taught master student, you get to engage with the research programs as well. So we've had a range of programs looking at the digital agricultural technology end of it, looking at, for example, algae extraction. We have a spirulina project that's running at the moment. We look at different supply chains. We look at biosensor development. So there's a range of these international projects that are funded. We have PhDs and master students running on them, and you get to cooperate with them as well. And you get the experience of working with a dynamic research team as well. And finally, where are you likely to end up working? Well, our graduates tend to get full employment. So they get employment in a range of different areas, whether that's with local authorities across Europe. So we have some working in Ireland and France and Germany and Scotland. We have them working with waste management companies, with energy companies, with electricity, with Siemens, both here and internationally as well, in Denmark, in the Netherlands, in Italy. We have graduates working with Siemens, with RPS consultancy companies. But interestingly enough, a number of the graduates also start their own businesses, providing consultancy advice. So, for example, some of the larger companies who are looking to pivot towards a more energy efficient, a more carbon neutral environment, they will bring in some of the graduates as advisors or consultants to them. So a number of our graduates have gone into that space, and indeed a number of them have gone on to carry on and doing research with us as well. So there's a broad range of areas and opportunities for our graduates to work in, and we tend to support them getting employment, getting their first steps on that ladder, and introducing them to companies who have an interest in this area. So that's a really quick overview of what we're doing on sustainable energy and green technologies. And as Katie said, if you have any questions, please put them in the chat and we'll deal with them afterwards. So Laura, I'll pass back to you again.
Great. Thank you so much, Kevin. So the next speaker that we have up is Professor Enda Cummins, and he is our program director for our one-year program in food engineering.
Thanks very much, Laura. You can hopefully hear and see me. My name is Enda Cummins, and I'm the program director for the Masters in Food Engineering. The food engineering program, what is it? What is it about? Well, the objective of the course is to educate scientists in the scientific and technological aspects of food manufacturing, food processing. So very much dealing with the technology associated food manufacturing and food processing. Provides a comprehensive coverage of bioprocess and food manufacturing systems and a broad knowledge of engineering technologies for food production and food processing. Several different aspects in it in terms of food and bioprocess engineering, risk assessment dealing with sort of safety aspects, process development and control, advanced manufacturing systems, and of course there's a whole myriad of environmental issues around the production of food, life cycle assessment, water usage, energy usage, and all that as well that's covered in terms of associated environmental issues also. It's the only food engineering program in Ireland, and we have been running this program quite successfully for over 20 years. Paula has already illustrated some of the staff from the school's perspective in terms of being highly cited and very research active. Just to reiterate that point in terms of some of the personnel that feed into the food engineering program, we're a highly research intensive school with several European Research Council fellows funded through the school, and we've hosted a number of Marie Curie fellows in the school in the past also. So this sort of ensures a practical and contemporary learning experience. Some of the facilities that we have developed, Paul has already alluded to some of them, but in particular, I'm just highlighting the state-of-the-art facilities in relation to spectrophotometry, hyperspectral imaging and chemometrics in the school. And Professor Stow and Son and Colin McDonnell, and indeed a number of others, as Paula highlighted, are also highly cited and contribute into the programme. Knowledge competencies throughout the program that we hope you will attain include novel food processing technology, food process automation, experience in relation to risk assessment. So there is an element around food safety, food quality as well in the program. Computer vision for food quality and food safety, life cycle analysis dealing with the environmental issues, as I've said, waste and energy implications for food manufacturing systems. We don't work in isolation. There are, of course, environmental issues around the production of food, and we have modules that cover those topics as well. And of course, the wider area of time management and project scheduling, also in terms of conducting your project and managing a project that you conduct as part of this as well. Practical skills: identify and understand the scientific underpinning of technology for food production and processing. Novel food process technologies. You'll carry out a risk assessment for the production of safe food, carry out a life cycle analysis for different food products, understand and assess the full range of health and safety issues around working in a safe workplace, use a range of field laboratory office equipment in an efficient and safe manner. Again, linking in with your project, devise a scientific hypothesis and carry out a course of investigation, applying appropriate measurement techniques, statistical analysis, and interpret findings around a topic of your choosing. That, if you like, allows you to specialize in an area of particular interest to yourself in the form of a project or a thesis, a final thesis. And then to be able to communicate also to scientific and non-scientific audiences in terms of oral presentations. Who's it for? Well, it should be of particular interest to graduates in engineering, science, and related disciplines, particularly those who have an interest in food and bioprocess engineering. The teaching methods, it's very much face-to-face delivery, so lectures, tutorials, hands-on laboratory practicals, and individual team projects as well, particularly in relation to some of the project work and health and safety assignments and so on. As part of the projects, you are assigned a student mentor to help you with your project, so it's not something that you would work alone. We would have a number of PhD students or postdocs that would also help and assist you in relation to setting up your project and helping on a day-to-day basis. It's a one-year full-time program with a September start, and the class profile, typically national and a cohort of international students, but predominantly international students in recent years, I have to say. Ireland's food sector, the food sector in Ireland, it's the largest indigenous industry with output over 14 billion. 45% of that is exported. And I think no matter what happens in an economy, people will always have to eat. And hence I would always argue that there will always be opportunities as a result of that for graduates with experience in relation to food manufacturing, food processing, to be able to cater for feeding that population. Paula already presented a number of graphics for some site visits. This is our site visits for our engineering, food engineering group at the Guinness store. So that was one of the site visits carried out. The program structure consists of 60 credits of modules that you take in semesters 1 and 2. And then a remaining 30 credits in terms of a year-long thesis. The thesis, as I've said already, is a research topic that you would select a topic of interest to yourself. You would have an academic supervisor and a student mentor to assist you in relation to that particular topic. It's a central food processing team, but balanced with modules on personal development and environmental implications also of the food industry. Computer literacy is also something that's developed throughout the program in terms of, well, risk assessment. For example, you develop some skills in relation to modeling, computer modeling, and setting up a safety statement for a particular food process. This is an indicative curriculum. I won't dwell on it, but just to highlight the sort of range of topics from core food engineering topics like bioprocess engineering, unit operations, environmental issues in terms of life cycle assessment, waste to energy, food refrigeration, risk assessment in relation to the safety aspects. And you have the thesis as well, which is a year-long module conducted by candidates as well. In terms of employers, just maybe some of the names that might be familiar to you in terms of past graduates and where they end up include, like, in Guinness, Project Management, Coca-Cola, Kerry, Glanbia, Bord na Móna. All these have taken on a number of graduates over the years and offer career opportunities and graduate. Some of them would offer postgraduate positions and would have information days organized on campus as well to advertise those positions as well. So with that, I'll stop there, and if there's any questions, we can take them at the end, but I'll hand back to Laura.
Great, thanks very much, Enda. Our last but not least program director that we have presenting today is Dr. Dimitrios Agropoulos. As I said at the start, it's for our newest program in digital technologies for sustainable agriculture. Dimitrios, if you want to start your presentation.
Thank you, Laura. Thank you. Yeah, my name is Dimitrios Agropoulos, also from the School of Biosystems and Food Engineering. And I am the program director of the new Masters in Digital Technology for Sustainable Agriculture. But before I introduce you to this master's degree, I would like to give a definition for digital agriculture, just to explain what is meant by digital agriculture. Digital agriculture is the integration of new and advanced technologies into crop and livestock farming systems to enable farmers and other professionals in the sector to improve food production. The program, therefore, is aimed at students who wish to build their knowledge and skills base to address the complexities of developing, deploying, and managing digital technology in the agricultural sector. But what makes this master's degree different? The program focuses on design, hardware, and software technology, and our students will be deeply engaged with agricultural production and specifically technology to enhance efficiency, sustainability, and resilience of the food system. The program offers hands-on experience on a range of novel digital technology, training in state-of-the-art labs, and applied research in a real-life environment at the Lions Research Farm. Digital agriculture or digital technology for sustainable agriculture represents the only program in Ireland and one of the few ones across the globe, across the world. All modules in this program are optional and will be delivered mainly face-to-face, including blended and intensive delivery formats. In other words, students will be able to take thin clusters of modules around precision farming, modules around sensing technology or programming, to reflect specific technical interests or needs for upskilling. Also, an applied work-related research project will be taken in the summer trimester. As Enda and Kevin mentioned earlier, the program is delivered by a highly research-intensive and multidisciplinary school, Ireland's premier agri-food-related research entity with excellent networks into the agri-food industry and with a particular focus on working with the industry to provide sustainable technical solutions. Examples include some recently awarded European projects like the Horizon Europe Watson project on digital tools for traceability and authenticity in the food system, with 44 partner organizations across 19 European countries. And our school is leading this initiative. Or another example is the European project Farmtopia on digital farming technologies for small and medium-scale farms. The masters will prepare students for an agricultural career with a special emphasis on the technical aspects of digital agriculture. And our graduates may find employment opportunities in the areas of agricultural machinery industry, precision farming, decision support in agriculture, Internet of Things, data, and predictive analytics. That's it for my side. Thank you very much. I will be able later on to ask any questions.
Grant, thank you very much, Demetrius. So now we have a bit more on the student experience to kind of give our attendees a sense of what it's actually like to study as a student with us. So we have Sagan, as I said at the start, he is currently doing our ME in Biosystems and Food Engineering, and he's going to give you a little bit about his journey so far.
Hi, I'm Shegun. So I'm just going to tell you about a couple of things I've experienced so far. I've been here in Highland for about 2 years now, I think. And I'm studying Biosystems and Food Engineering. Why did I choose Biosystems and Food Engineering? I had my first degree in mechanical engineering, and I had an internship in the oil and gas industry in the corrosion sector, inspection generally. And I also got exposed to some waste treatment technologies prior to discharge to the sea offshore. So I was looking to do a master's, but I'm not really sure. I thought I was going to do a master's on corrosion because of that exposure. But after graduating, I ended up in a cocoa processing factory. And I was still keen on the oil and gas sector, working on corrosion. Long story short, on checking on top schools around the world and the courses that could fit into my background, I got to see Biosystems and Food Engineering, UCD. And I saw that it entails some of these things that I've learned before. It's basically divided into 3 major sections: food processing, the energy industry, and sustainability. So, I mean, yeah, environmental, social, or in terms of economic, which caps it all. So I saw it as a great opportunity for me to develop further on what I've started. That was why I choose it. And what's the value to me? To me, the value of doing the master's is that I get the opportunity to connect globally to solve global problems. And I said that because I get quality information from the school, from which I base my creative abilities on. I mean, from which I extract information to provide some simple solutions from my mental evaluation. So the basic thing is that you get good information, qualitative information, and current information from your PowerPoints that are being presented to you and facilitated by the lecturers. What are the added benefits? Like I said, is you have quality knowledge, and the way the knowledge is presented is in a serial form. Like you're getting it in parchments, building up knowledge in parchments, and it also connects you to reality. what is happening in the industry right now. Even if you go, you may likely take some courses even outside the school you are studying, maybe related to your course. Like I took a particular course in mechanical engineering, which is thermodynamics, engineering thermodynamics. And it was so valuable to me because I saw the impacts. I had taken the course before where I came from in Nigeria, but the way it was taken here is different. And the quality of the information is very, very, very high. It's already been extracted and presented in a simple way, graphical forms, and then connected to what is happening currently. And you'd really appreciate it, what you're getting. And also there is real-time evaluation. I mean, if you have difficulty in doing something, doing an assignment or a practical, or what you're meant to do, you'd be given guidance afterwards on how to approach it. So it is very important that you take every present moment very seriously, like you're doing an exam every day. Yes. Also, there are many interesting contents in the course in biosystems and food engineering, starting with biomass evaluation, like different biomasses and how you could valorize them and the technologies that are involved. There's one that I'm keen to, it's called the Green Biorefinery. Like the course is centered on sustainability, as I've said. It means you want to use better what you're using right now or develop some other technology to replace what you're using already. So from a particular input substrate like grass, instead of using the whole grass, for instance, for feeding just the cattle for milk production or beef production, I learned you could extract the juice and then use the protein content of that juice to feed chicken and pigs, which will produce greater protein per unit of what you're feeding compared to the cattle. And you could still feed the cattle with the press cakes that are left, if that is feasible. And also, you know, it's all about valorization. It means you don't want to generate waste. And if there are waste that you cannot get rid of, you still can valorize them. Say, if there are, say, animal feces or slurries, you could use them in generating biogas or some valuable biofertilizer instead. So it's circular economy as well. It's the bioeconomy. And my focus right now in my career is to, I recently got an offer, which is EU funded, to join in the development of a tool to provide a supply chain solution. I'm thinking that would have to do with saving delivery times of resources, using digital tools, reducing the influence of humans or labor, human interference. And I think that's going to reduce costs as well and impact the globe in terms of delivery of feedstocks or products. So that's all I have for you. If you have any questions for me, yeah.
Great, thank you so much. That was really interesting, and I'm sure for the attendees to get that student experience is really important. So I think we're going to open it up now to our Q&A kind of session. So as I said at the start, if any of our attendees do have questions for us, now is the time to get them answered. Please type your questions in the Q&A panel, which is at the bottom of your screen. Or I know Katie has also received, my colleague Katie has received a couple of private messages as well, so she's popped them in the chat. So we'll go through them as best as we can, and we'll get through as many as we can in the time that we have left. So I'm going to kick it off. I think one of the first questions Katie got through was a private message, and it was just, and I'll throw this to any of the academics or to anyone who wants to answer it, was the school seems very research intensive from what everyone was saying in their presentations. And how many of your graduates actually go on to research if they're looking at research masters or PhD programs? And how does the research feed into the teaching, or does that have an impact on the teaching that you have within your programs?
I'll just kick off with this one. So yes, the school is research intensive, and what that does is it does offer opportunities then for our taught graduates to enter into those research programs if a position is available, for example, for a PhD research program. It isn't a direct route, but we do, the opportunities are there, and sometimes when people choose their dissertation, their thesis topic within their taught master's program, that is very often aligned with a research group, so they kind of get exposed to how research projects are running, and then they might get the idea that maybe to do a PhD is what they would actually like to do. And then, we certainly at school support people applying for funding to pursue a PhD themselves, but also that PhD positions do come up from time to time within the school, and there is a certain percentage, a certain cohort, I suppose, within our taught graduate programs every year that do actually stay with us and then start developing their PhD programs with us here at the school as well.
Great. So it's good. It's great to hear, I'm sure, for attendees that there is opportunities there. And not everyone starts out going, I want to go into research, but potentially over the course of the master's program, they might realize it's something that they really enjoy. And the fact that there is opportunities is really good. So another question that Katie was sent as well was just, how much freedom or flexibility do students have when they're choosing their topics for their dissertation or their minor thesis? And are all of them pre-assigned, or do they get a level of choice within the programs?
I can take that one, Laura. Yeah. I mean, typically there's a list that is generated by the school, and the list of topics aligns with the expertise of the professors in the school. So, if you're interested in a taught program in our school, it obviously aligns with the interests of the professors in there also. So there should be something for everyone in relation to whether you're interested in the energy side, the food side, or the environmental side, or the digital agriculture side. So there is a list that aligns with the experts of the professors, and as Paula said, typically would align also with a research project, mean that would be ongoing with the professor and their team. So there is considerable flexibility there, but obviously it has to align with a topic outlined by the academic in the school.
Okay, great. Thank you very much, Enda. Another question we had in was just relation to, obviously for most of these programs, we get a lot of engineering applicants, people who have an undergrad in engineering applying for them, but many of them will also take ancillary disciplines or people from other disciplines. So what are some of the disciplines that you see you're applying for your programs? How do these students get on as well, do you find?
So I might take that, Laura. So certainly for the sustainable energy and green technologies, we would have students from a wide background, from a whole range of different sciences backgrounds, architecture, geography, engineering as well. But we are not restricting it to engineers only. So we would take students from strong academic backgrounds in a range of coherent subjects or compatible subjects. It's really, we assume the students don't know the topics coming in, but that they are technically competent and can come up to speed quite quickly. And we bring them through that introduction modules quite quickly. So that's why we're quite flexible in the Sustainable Energy and Green Technologies program to allow students from non-engineering backgrounds to take that. So it is a more science-driven program rather than an engineering program. Enda might refer to his because his is more an engineering-focused program.
Yeah, I suppose just to add to that, Laura, in that we would typically have applicants from engineering, science, or related disciplines, whether that is food technology, food science background, and so on. I suppose the one exception to that is probably the ME program, and maybe that's kind of where that question maybe derives from, in that for the ME program, you must have an engineering degree. It is directed towards ME students, and that is Segun's background. He was had an engineering background, an engineering primary degree. So for the 2-year ME program, you do require an engineering degree, but for the other programs, engineering, science related disciplines are most welcome and secure positions on the program. And just while I'm speaking, I just see the follow-on one is internship, which is sort of related. Because the one-year programs, the sustainable energy, the food engineer, they're one-year intensive programs. So the internships do not form part of that. Even though you may be working alongside a company as part of your project, an internship does not form part of that because it is an intensive 12-month program. The ME, which again, Sigon might be able to comment in relation to, is a 2-year program, and the internship does form part of that program. So that's specifically directed towards the engineering cohort, and that is more, it's extended over a wider period of time, and that does allow for the internships to sit in there.
Great,
So
thank you very much,
that answers
Kev.
that.
Yeah, I think it does. Thanks, Kevin and Enda, for that. So yeah, for attendees listening in, I think for some of the programs where you are taking people from different backgrounds, I think the learning experience would be quite good in those classrooms where you're learning from people from diverse backgrounds, different
Laura, same
disciplines is good.
applies to digital agriculture as well.
Great.
We take students from different backgrounds, including engineering, science, agriculture, biology, and food as well. Yeah.
Brilliant. That's great to hear. So yeah, to expand on the internship question, Segun, you're obviously doing the program that has an internship embedded in the curriculum. If you wanted to comment on that for us, for the attendees listening in.
Yeah, so the internship, it's a compulsory program for your for the ME course in Biosystems and Food Engineering. Usually you'd go for 6 months internship or placement as one of your modules in the industry, and that will facilitate your understanding in case, in the sense that you're going to have some ads on and then real job situation.
Yeah, and are there supports available to students while they're looking for that internship, or how does
Yes,
logistically does it work?
There are supports. You usually you'd have some companies coming around to the school. There's a particular window for that, and then you'd have to submit your CVs and then do some interviews with different individual companies from which you could be picked for your internship. So you have a fair career fair, and that, yeah.
Great. Yeah, we also have, just to highlight that we have 2 internship managers within our college who do a lot of that relationship building and company selection, I suppose. And they would propose and work with the companies to propose these placements for the students. And as Segun said, that students are interviewing for them. So sometimes it's their first instance of interviewing for a technical role, which is a good experience within the safe confines of the curriculum, I suppose. And most students find this aspect of the 2-year program really beneficial. And a lot of companies will use it as an extended kind of job interview process, I suppose, with many students who do well on the placements actually securing a job offer from that company for when they finish their degree as well, which is I'm sure quite exciting for the students and takes a lot of pressure off maybe going into their final set of exams, knowing they already have a job to go into, which is great. Then we have one more question. I think, Segun, it's for you as well. Obviously, you're not from Ireland, you're from Nigeria, and you chose to study abroad with us here for your master's. How did you find the transition moving to Ireland? Was it easy to settle in, or do you have any tips for our international applicants potentially?
Yeah, it wasn't so easy to settle in because I came during the COVID period, the lockdown period, and I couldn't find people to relate with. I couldn't find Nigerians around, and but I would say, I don't know how the things, current state of things are now, that things are better now. But I would say you find your group once you come in. For instance, you have some, I'm a Christian, and for instance, you have some Christian fellowship around, even in UCD there. You could join one of them, and from there, you get to meet people and familiarize yourself with the surroundings.
Yeah, great. I think that's a good point. There's so many clubs and societies that UCD has an offer for students, and it is a really great way to meet people from outside your course, from other areas as well. Being able to do things, outside the classroom, I think is really important aspect of studying with us here in UCD. So thanks for that. I think that's all the questions we have time for. We've kind of reached the end of our webinar today. I did just want to say a big thank you to all our speakers for joining us today, for giving insights into your programs and your experience so far. Thank you to everyone of our attendees who joined us today. Just again, to remind you, we did record the webinar today, so it will be up on our YouTube channel early next week. If you want to check it out again, or you missed anything, Katie, my colleague, did pop a link to that earlier in the session. Also, just might ask Katie to pop her email and my email address in the chat as well, just so if you have any follow-up questions after today, you can reach out to us directly, and then we'll get a response back to you that way as soon as that we can. So Katie's just popping them up there now. But that's all we have for today. So thank you very much for joining us. I'll ask our speakers, you can all leave and our attendees can leave, but I might leave the webinar just open so you can grab those email addresses real quick. But thank you again.
Thank you, Laura. Take care.
Thanks, everybody.
Thank you.
Thank you, everybody. Bye-bye.
Thank you. Bye.